Hey all, thank you so much for joining this month's session. And this month we have quite a few topics which were piled up. So let me go through this real quick. This is our meetup group, and this is monthly event. And this month we are having multiple sessions. I'll start with a little bit on Aspire, how to work with JavaScript apps with .NET Aspire as part of the distributed application. We'll see that. And then we have singleton ChatGPT clone will be done by 4 members. One is Manikanta. Manikanta, could you please come on screen?
Yeah. Hello all. Myself Manikanta Gandhi.
And
I'm a
followed
PhD student.
Thanks. Next, we will have Sreelekha, who will be discussing on how to create a simple Flask API and integrate with OpenAPI. Sreelekha?
Hello everyone, I'm Mucharla Sreelekha.
Thanks. And then Tejasri will be discussing on React UI, React 19 UI with Tailwind. Tejasri?
Hello everyone, my name is Medishetty.
Thanks. And the final session is how do we integrate React UI and the Flask API? And dealing with CORS will be spoken by Soumya. Soumya?
Hello everyone, I'm Soumya.
Thanks. So I think my screen is in share. We will get going. Okay, let me adjust this so that we'll get extra space on this one. Is my screen visible? I hope my screen is visible. Let me check once. Share. No. I'm not seeing my screen. I'm sorry, I didn't add my screen. Sorry for that. So I think now my screen is in share. Let me check that before we going further. Okay, so I think today's topic. So the first session is on working with .NET Aspire with JavaScript applications. So I thought of starting with .NET 9 instead of .NET 8. Okay, first I'll execute this. I'll show you. Then slowly we will discuss a few other points, and then we will go ahead and create it one ourselves. So what I'm doing is I am having this application at opened in 2 different versions because I mean 2 different IDEs. One I opened it in Visual Studio. The same solution the same folder I opened it in the VS Code also. Here, if you see in Visual Studio 2022, I just opened the solution, but some of the JavaScript applications that will not appear there might be in future, it might, but instead we can come and watch here from the VS Code. So let's start with that and see some of the things which we'll cover is .NET 9 Aspire, and we'll see that what is new in .NET 9 Aspire, and okay, we'll try to learn some of those things from here, as well as the template is with .NET SDK. We'll create one ourselves in 20 minutes from now. First, let's see that how to integrate, how to incorporate, what other changes do we need to do. If you see that the SDK we are using, .NET 9.1, that's the latest one. I mean, 9 was there. And on top of that is this one, .NET 9.1. Okay, that's the one which we are using it here. And let's first execute it and see some of those things, what is new in .NET 9. So we'll leave this .NET upgrade aside, and we'll see that tooling improvement. We'll see something about the tooling improvement. You can see here, we will have .NET 8 or .NET 9 and a Docker desktop. We need to have that. And you can directly install this templates. Okay, to install this .NET templates, we can do that. And then we'll see all these .NET templates over here. And runtime dashboard, particularly on this tooling perspective only. So we can add those all these integration points, we can add it, and hosting packages are there. So a lot of the tooling and how this application looks. All the .NET projects are in .NET 9. So the framework is .NET 9. You can see, and you can come here and see .NET list SDKs. So you see that 8, 9, and 10. So I have 10. I think 10 they would have released the preview to. I think it's a good thing to get going if you want to stay on the bleeding edge of the technology. So other thing is, once the dashboard has been here, so tooling improvement and templates have been moved. So you can install the templates. Previously it was another command, and we see that dashboard enhancements. So manage resource lifecycle. So this is very important point for us to discuss the lifecycle things. First, let's see how it executes, and then we'll come back. So this is a weather API. I can click on this, and that goes and brings the weather API. Let me duplicate this so that I can show you the structured logs over here. So anything which we do, all these things will get displayed here, all the logs. And I have added the Swagger. And before going to Swagger itself, we will have the OpenAPI one. OpenAPI, and see that it displays the OpenAPI v1 JSON. And that's one of the point. And the second point is we have the Swagger. We can integrate with Swagger, or we can integrate with the Scalar. So I just integrated with Swagger. The Scalar is a new one. It's very simple. And if you see in the host project, sorry, it's in a API project. It's in a API project. If you see that, add OpenAPI. Previously, we used to have the Swagger related one, but now OpenAPI has become part of the .NET framework. We are not depending on any third-party libraries. So generation of this OpenAPI is now part of the .NET framework. And from the perspective of the visual UI, so when you do add that OpenAPI, this is what you will be able to see. Okay, you know the schema. And the OpenAPI definition is here. Now, if you want a visual interface, that's when you need Swashbuckle. And then inside the program.cs, you need to add this one particular line, use Swagger, and you need to specify where is the spec file for this one. Okay, that's when you will be able to see this visual interface. Now you can go and test this in here, right? We are seeing this. This is one point. And the second point is, we'll come back and we'll see, are there any logs or traces? That's for the API. Did we do anything? Yes, we did a couple of executions. Let's do a couple of executions and come back and see that whether it is showing those traces, structured logs. It will take time, but it will definitely show those. See this here. Whenever we hit this, we went to OpenAPI documentation as well as we came in here. All the traces are here. Okay, I'll leave it there and come back to console. And inside the console, we were hitting the API. So whatever the API gives the console, it shows it. And this is the console for Angular, and this is the console for React. Okay, and this is the console for Vue.js. And let's see the Blazor frontend. So now we saw from this resources perspective, we saw different things. We just looked into how the weather API, how it is being interacted. One more important thing when it comes to the local versus the hosted app. So right now, if you see that here for the web API, we don't have that with external endpoints, which is there for the Blazor frontend, which is there for Angular, which is there for React, and which is there for Vue.js. But here in our local, we are able to access it. Once it deployed to the Azure Container Apps, then you will not be able to access this one because it will not allow it. So where can we see that is when you go to Aspire manifest. And inside this Aspire manifest, you can see this API. You have this bindings. It shows this bindings, but when you compare that with the Blazor one, external equal to true, external equal to true. So you see that that element is missing. So that means it will not enable the ingress to this API. That's when you deploy. So at this point of time, because you're working in local, we will be able to access it. Now we'll see that front end. So in this front end, if you see that, I have opened the dev tools. We are using Redis cache also. And you can come and see this is the Redis container which we are using it, which will be used to hold the cached data. And you can see here, we are clicking on weather. And I just want to see, this is the weather information. Just give it a minute. Just 1 minute, please. It's getting the weather fetch data. It says we got the response. Okay, just let me stop this and start 1 second. Okay, I'm here. Let's give it a minute, 1 second. So we just saw only the first piece, the API. Now we'll see the Blazor, and we discussed the Open API. Now either API will also blend or go with Scalar. So let's wait to get the control. We got the control, and just click on this the dashboard, and from there we went to this weather forecast. Oh, I think I know that. What is that? Weather forecast. 1 second. This one. It's not API service because I changed the name. I forgot to change it here. It is weather API. It's API service. It's an entire solution. Let me find all real quick. So okay, here. So that I have to change it to weather API. Okay, that's one instance. And where is the other instance? It's in this one. Okay, that's cool. That's the mistake. I forgot to change that. Now let's see this. Just give it a minute. It will come. So it's starting this Aspire application, and it will show the dashboard. Okay, the dashboard has the box is a little slow. Let's wait. Okay, the dashboard has come. So let me create a duplicate of that, and I'll go and from here we just saw the API part. Now let's go and look into the Blazor side also. Now we can see this. We can come back to the Blazor app. When I click on weather, we can see that it is trying to go fetch the data from. So you see that it has bought this one. And now if you observe it, we'll do another fetch. You see that 18, it didn't change. So I'll just filter it out only with weather. Okay, so we'll come to know that. Now we'll observe that it will be for 5 seconds. So the first hit, it is 4. I'll do a second hit. It shows 4. Third hit, it still shows 4. Fourth hit, you see that the first one was 4, now it has changed. So what happens is here, because it is using the cached information, so it loads the data from the cache. But after 5 seconds, you can see that that is bringing in the content from the API. So that the same thing we can see here in the structured logs. So after so many hits, we'll get the content. You can go and we will be able to see that in the structured logs as well as in the traces also. We'll be able to see that. Now see this is the front end and how many calls did we do from front end. And you can see this other front end, you can see it will be weather, and other times you go to weather, but still it's going and getting this information directly from the cached one. So now what we will do is we will go and look at the Angular side. So for that, let's go and look at the console of Angular over here, and it is ready. So we'll go ahead and click on the Angular here. It is npm start, and you can see that it is displaying the weather information. And let me drag this little on this side, and again I do a click on this, and let's see, we are on the weather side. You can see this weather forecast, and that is bringing in this values. So you can see 150. Now I'll make another call to this, and it is bringing in another set of content. So you can see that whatever we are doing those actions, if at all some error pops up, it will be here. It's technically the console of Angular. A little slow today. So you got this 30, and again I'm clicking on this. So now it is 15. I'm speaking about the first row over here. 33. I mean, technically I should have a button here. I click on this or auto refresh every minute or 30 seconds. I should have done that, but I just did a straight lift of Microsoft sample, and I'm using it. But technically, this helps us to come look at the structured logs or the traces over here. Now you can see those traces. We have it on the weather side. You can see all the hits, whichever it is coming in from the Angular UI, it is hitting, because these two things we are tracking it over here. The weather, here in the structured logs, we are seeing that the weather API and the UI, the Blazor UI. So you'll get a lot of these structured logs. And on top of this, what we can do is sometimes, if at all this application did not start for some good reason or bad reason, but what we can do is we can click on stop. So that will go and stop this. Again, we can come and look at the logs. So you can see that it has stopped it. And I can come and click on start. So it is starting. We can come back to this console, and you can see that it is starting on the port, and now it will be available to go and look at it. Now again, I'll do a fresh hit to that, and you can see that it is building. I mean, it takes little time, but it will flush out the output. Okay, it is ready now. I think we should be able to see the new content over here. Technically, I should have done with the button. Okay, that's about this one. Now let's see the React app. And the React app has come real quick. Let's again go and look at the same way how we did it with the weather API. So you see that the weather API, it is getting. When I compare that with this one, It's the same JavaScript flavored apps. You see this? It's getting all this content. See, where is the value? Value is -3. It's not freezing. I think this is the one. Yeah, -3. It matches -3 and -19. And that's about the React. And if you see the Vue.js, which I found it blazingly fast. This one you can see, I mean, might be the color should have been a different color, but you can see that here it does fetch a similar thing. You can click on this link and do this one. So you can see this, you can see this. That's how it goes and brings it. And another important point for us to watch is the dependency. Okay, we'll see that. I'll show you in a different way, but I'm just trying to see this. Now we can stop for some reason and want to test a negative scenario. How the UI looks this way. Now again, you can come back and start. Now it is back. Now you can go back and click on this. It is coming. Okay. Now this all we discussed, like how we will be able to work with an .NET Aspire solution, which has got .NET 9 minimal API, .NET 9 Blazor application. Can we bring in the JavaScript applications into the mix? So that was the thought. So it is very well and very easily possible. So how do we do that? So let's spend 5 minutes on the theoretical part. So this is the Angular 19. Okay, this is Angular 19 app. And you can see that you can create a new folder within the same solution. If you see this Aspire with JavaScript, inside this you can create a new application. After doing this new application, you need to ensure that proxy configuration so that it will be able to hit the backend. So for that, how do you know that endpoint of HTTP or HTTPS is that you need to come in here in the app host and see the manifest file. So inside the manifest file, when it shows the API, weather API, so here you will be able to find out the endpoints over here. And how the endpoints will be. Here you can see that the endpoints, it clearly displays these endpoints. Okay, so how do you create the manifest file? So inside this launch.json, you can add creation of manifest. So the command line arguments is publisher manifest, output, what should be the manifest file. Okay, so what we have to do is we need to switch the profile to manifest. And you see this right now, the manifest has got only Angular front-end API, but it doesn't have anything for React and Vue.js. Now I'm executing the manifest. It will come. Should be in this window. Okay, so it displayed the manifest and it is saying that it has completed the manifest display. So now you see this weather API we have already seen. This is for the cache. I'll close this, and weather API I'll close, front end I'll close. Now we have Angular, and now you can see that it has created for React, and you see this, and that you can correlate in this proxy file. So services, weather API, HTTPS 0. You see this services, weather API, HTTP 0. and services weather API HTTPS 0. So HTTP and HTTPS 0. So node environment mode is this one. And similarly, you can come to React over here, and you see this. The React is there, default template config, and here also you see this. The what should be the URL that is being passed in here. Okay, here also you can see that the default config template, it's asking to use the HTTPS, and that's one thing. And additionally, we have the proxy config to route it. And here also you can see this, it is using the HTTPS. Both are building to a image. So let me close these two. And let's look at the Vue.js, and then we'll see how it is getting integrated. I'll be done in next 2 minutes. So we'll come in here. We'll see it's passing that weather API. We know that how to generate the weather API. I mean the endpoint. I'm sorry for that. How to generate the endpoint is a key thing, and we know that how it generates. And after that, what is very important over here is when you are integrating it. So let me come back to this program.cs. So inside this program.cs, if you see that just the projects dot aspire with JavaScript API. So that means it is pointing to this. When we say that projects dot aspire with JavaScript web, what is this? Who is creating? Just control click on that. It is just a metadata. You see that it is having only one parameter, that is project path. So when you add any project to the solution of .NET type, and when you are adding it as a project, so that means you are referring to a physical path of that project. Okay, you're referring to the physical path. It's the metadata which is getting generated. You can see that that's the metadata it gets generated. When you're using this class, whatever we are here, the dot is replaced with underscore. That's a metadata. It has got the physical path of that. And when it comes to the JavaScript applications, what we do is we'll do the add npm app. So this is just a name. You can have any name. You can have ng19 or whatever the label. It's just a name. And where is a physical path, working directory. So that's what we are giving. That is one different. And port we are passing it. And because we have to access it once we deploy this to Azure Container Apps, we need to access it externally. So any applications, the front end side of the applications, that should be the external apps. If at all you have front ends, and that is for the external users, we need to enable the HTTP with HTTP external endpoints. And something which you want to keep it within the network and the subnet or some kind of, it will be restricted. So APIs and all those things will be there, as well as any internal apps which you want only to a particular network or private network, then you can stop enabling it and it should be used from that. Mostly it will be the API which you don't want to expose it to the external world, but the front ends you have to expose, and some of the things which you want to keep it internal, and again you need to have a jump box kind of thing to go and access it. I mean, it depends upon, or you are punching the hole or establishing a tunnel from your access point to that browser. That's a different discussion, but generally all the front ends will be having that with external endpoints. And another thing is wait for. That means if at all the API did not start for some reason, so these things will not start. So if the cache is not available, then this will not start. So it's like that. Okay. So I think that's it from my side for this session. Thanks so much. And let's go to the second session, which is Manikanta session. And Manikanta, it is all yours. I'll go on the backstage.
Yeah, sir. Yeah. Thank you, Swami sir, for this wonderful session. Good morning, guys. I am Medishetty Manikanta Gandhi, a BTech third year student. I am thrilled to kick off our session today with a deep dive into building a single-turn ChatGPT clone, which is our first turn. First thing first, I am still a learner. Apologize if I do any mistakes. And please fasten your seatbelts. We will rush into the session. Today, we are surrounded by AI-powered applications, and conversational AI has taken center stage. From customer support chatbots to personal AI assistants, these models are shaping the way we interact with the technology. But have you ever wondered what it takes to build one? That's exactly what we will explore today. In this session, I will guide you through the fundamentals of building a ChatGPT style app using Flask, Azure OpenAI, React.js, Tailwind CSS, and more. We will cover a quick introduction to Flask and Python for the people who are new to these technologies, and the architecture of our application, and how we build backend with Flask and Azure OpenAI, design a dynamic front end with React and Tailwind. By the end of this session, you will have a clear understanding of how AI powered chat applications work and how you can build one by yourself. Before diving in, for the people who don't know what is Python and Flask, before diving into our application, let's take a step back and talk about Python. Python is one of the most popular programming languages today due to its simplicity, readability, and vast ecosystem of libraries. Python is widely used in various domains, including web development, machine learning, and automation. It's an interpreted high-level language with a clean and readable syntax. It has a huge collection of libraries and frameworks that make development easier. It is widely used in artificial intelligence and machine learnings due to libraries like TensorFlow, PyTorch, and OpenAI's GPT model. And coming to Flask, Flask is a lightweight Python web framework used to build APIs and web applications quickly. Unlike Django, which is most featured package, Flask is minimalistic and gives developers flexibility. It allows you to create web applications with minimal boilerplate code. It has built-in support for handling HTTP requests and responses. It integrates well with machine learning and AI models, making it perfect for our ChatGPT clone. We are using Flask as a backend of our chatbot because it provides a simple and scalable way to handle API requests. Now that we understand the basics, let's move on to the architecture of our application. Let's let's start by understanding how our singleton ChatGPT clone is structured. At a high level, our application contains the following components. We have a backend We have backend API with Flask, Azure OpenAI services, frontend and frontend with React.js and Tailwind CSS, and authentication. Overall, when user interacts with the frontend which is created using React.js UI, it will trigger to the Python Flask API, and the Python Flask API triggers the Azure OpenAI, and it will give response back to the Python Flask API, and the response is given back to React, and we will see the response. Flask serves as the backbone of our application, handling user requests. It receives chat inputs from the front end, sends them to the Azure OpenAI, and returns the response. And coming back to the Azure OpenAI service, instead of running our own model, we integrate with Azure OpenAI. Azure OpenAI provides scalability and efficiency, allowing us to generate high quality responses using Azure OpenAI's powerful language models. We are not generating our own models, we are using Azure OpenAI services. And coming to front end, we ensure a smooth user experience by dynamically updating the UI. Coming to Tailwind CSS, it is used to style our app with a modern and responsive design. And in future, we will apply the authentication using auth-o. This is the architecture of our application. You can see in our file we have backend and frontend folders. In backend we have services which we use from Azure OpenAI services, and we have API which is used to communicate with Azure OpenAI and Flask AI API. And this is the backbone of our backend. And coming to the front end, we have including React and Tailwind CSS, and we have JSON packages. This is the heart of our front end. And coming back to uh, coming back to Flask API with Azure OpenAI. Setting up the Flask. Now that we have an overview of our architecture, right? Let's focus on the backend. The Flask API that connects to the Azure OpenAI. Step. Flask allows us to create a simple API to handle chat request. The key endpoint is we have our key endpoint in API, which takes user input and forward it to the Open API. And integration with Azure OpenAI. Azure OpenAI provides GPT models that generate human-like responses. We send a structured request to the model, including the user's input and system's instructions. The model processes the input and returns a generated response. We will see in the demo how this works. And this API takes user input, sends it to the Open API, and returns a generated response. And coming to the front end. Coming to front end, the React UI. Our front end is built with React.js, allowing us to create a dynamic interface. When user submits a message, React calls our Flask API and displays the AI responses. And we have our styling in Tailwind CSS. Tailwind makes styling efficient and flexible. Our chat interface is designed to be clean, modern, and user friendly. And we can see the demo of our front end in few minutes. And in future we will secure our application with auth-o and more. Coming to the demo part, you can see our server is live now. You can do this thing by following the steps in this readme file. Let's check our model by giving this small prompt. Let's go to new terminal and see our prompt is what is an orange. Let's see how our model responds to this kind of prompts. Yeah, an orange is a round citrus fruit with a bright orange color and sweet. And if you see, let us say another prompt. What we can say, what is OpenAI? Yeah, it's saying about OpenAI. It's an artificial intelligence research organization and company. It was founded in December. It will give all the responses. The point over here is when you give this prompt, when user gives prompt, we are skipping this part. We will see our UI in just 2 minutes. When user gives prompt to Python Flask API, the request is passed to Azure OpenAI, and once the Azure OpenAI receives the request, it will generate the response, and the response is sent back to Python Flask API, and this Python Flask API collects this response and give back to the user. And since I have said we have developed a front end using React and Tailwind CSS, let's see how this works. Yeah, we have a front end server running here. Here, see, this is the front end we have created using Tailwind CSS and React.js. If we ask the same question here, it's thinking, and it has given a response. And if you ask what is OpenAI, yeah, it has given response for OpenAI is an artificial intelligence research laboratory and company. This is the thing we will do with OpenAI. This is a single-turn ChatGPT clone, which means while you have using ChatGPT, you have the history of the chats you have given to OpenAI model. But here, since this is a single-turn ChatGPT clone, there is no link between the current prompt and the next prompt. Every prompt is a fresh prompt, and you can't access the previous prompt once you have entered the new prompt. And if you observe, if you stop the server over here, see, I am stopping the server over here, and if I do any request from here, it will think, and it's a error fetching response failed to fetch. The point is, if we run backend and frontend together, this thing works. And if you won't run the backend server and you are running the frontend, this thing won't works. And again, if I run my server, and if I again give my prompt, it will give the response. You can check with number of prompts. Yeah, it is given the PM of India. And even if you want to do something with, you want to do coding, write a small code for prime numbers in Python, you can do that too. It will think and it will give you a response. Yeah, here you can see, here's a simple code to check if a number is prime or not. And not only these small things, we can do very big things with this thing too. How can I connect Flask API to Azure OpenAI API? You can do this too. It will think and it will give the process how can we connect our Azure OpenAI Flask API to Azure OpenAI. See, it has given the whole process. You can see the whole process over here. You can do lot of things with this thing, but the point is here you need to run this front end, you need to run this back end and this front end alongside. If you can't run front end and if you are running back end, you can't make the thing. And now you guys have seen how these things works, what we have built, and you are excited to know how we have built, right? In the next sessions, our speakers will let you know how the front end and back end has built and how they are integrated. Thank you.
Thanks, Manikanta. It was a good foundation of what you four have built, and your session was wonderful. Hope others would have learned something new. Thank you so much, Sreelekha. Is your screen in share? Is this your screen?
Yes, sir, I shared.
Okay. This one, isn't it? Okay. That's cool then. Go ahead, Sreelekha.
Good morning, everyone. I am Mucharla Sreelekha. Today, I'll guide you through the process of integrating Azure OpenAI into a Flask API, unlocking the power of intelligent automation in your projects. Imagine a world where applications understand and respond to users just like a human assistant. Think of ChatGPT, but embedded seamlessly into your own applications. Sounds exciting, right? In next few minutes, you'll learn how to build, deploy, and test a smart API that communicates with OpenAI's powerful models. We'll break it down step by step from architecture to real-time execution. Uh, in this session, we will understand the we will cover the topics of understanding the system architecture behind the Flask API using Azure OpenAI, and also walk through how the Flask API integrates with Azure OpenAI. And also, finally, we have a live demo where we send a request and receive an AI generated response. Let's get into the system architecture. First, we have to visualize the flow of our architecture. Before we jump into the code, let's first understand how the system works together, and let's take a look at our architecture. In our system, we used React UI for front-end purpose, which gives a beautiful user interface, and Flask API as backend engine which handles a client's request, and Azure OpenAI service which processes the request and generates intelligent responses. And finally, authentication and logging which ensures the security and monitoring. Now, let's see how everything connects. When a user inputs a prompt into our system, the React UI or a client sends a request to our Flask API. The Flask processes the request and securely forwards it to Azure OpenAI. Then, Azure OpenAI generates a response based on the provided input or prompt. Finally, Flask returns the AI generated answer to the front end. This modular architecture makes our system scalable and easy to extend with security and logging mechanisms. Now, let's walk through the code. This is our code structure. We have backend folders and front-end folders which contains the respective dependencies in the folders. Firstly, we have to focus on env file. What is a why we have to use env file? Env file is used to store environment variables in a key value format, which keeps sensitive information like API keys, database credentials out of the source code, while pushing the whole code or whole project into a Git or any version control system. Make sure not to push the env file. In env file, we contains the Azure OpenAI deployment name, which has the model name. The model name is GPT-35 Turbo 16K, and we have Azure OpenAI endpoint and Azure OpenAI endpoint, which is the Azure resource name and which hosted in Azure AI infrastructure. Then we have the version name and the respective API key. All these are embedded in our env file to work our system smoothly. Now let's get into the code. The main thing in the app.py, there are mainly 4 import statements. The first import statement is from api.homeroads import home API BP. Uh, we had imported home API blueprint from API homeroads. Importing home API BP means you will register it in main Flask app to manage the home related API endpoints. And the second one, from utils error handling import handle internal server error. This is for this command is for mainly for the error handling. The handle internal server error function might handle 500 internal server errors in Flask. And then from utils logging config import configure logging. This import function configure logging this import function
Sreelekha, please share your screen. Thank you.
from utils.login config, import configure login. This imports a function configure login from utils login config.py, which is responsible for setting up logging for the application. And finally, from api.completions routes, import completions API BP. This is similar to home API BP, which imports another Flask blueprint from completions routes py. Since the file name suggests completions, it handles OpenAI calls for generating the response. Uh, these are the home routes.py. From here, we imported the home API BP blueprint, and from logging config py, we imported the configure logging, and from completion routes, we imported the completion API BP, and we have these files under the API folder, and we have utils which contains uh, error handling and logging config, and then for each folder like backend and frontend have the respective readmes. With the help of these markdown file, we can execute our system. Now let's get into the main execution. First of all, we have to install Python and pip. We know Python is a high level language which is used to create which is used mainly for the OpenAI, and the pip is a Python package installer. This package manages the Python installation, updation, etc. And then we have to install the pip install virtual environment. So to create or to execute our project, we install the virtual environment, and then we have to create the virtual environment by executing this command. So firstly, I'm going to check the Python and pip version in my local system. Done. I have my Python and pip with the latest versions. Next, I have to install the virtual environment by executing this command. While we installing the virtual environment, if you already have the virtual environment in your system, you will get the all the dependencies are downloading, and if you have already installed, you will get these type of requirements satisfied. And now I'm going to create the virtual environment by executing this command. With the help of this command, we are going to create the virtual environment. When the virtual environment are created, we will get another name, like we will get the v in front of the folder name. Then we have to activate the virtual environment by executing this command. Firstly, we have to change the directory to the respected folder, projects folder. Now going to activate the virtual environment. After activating the virtual environment, we can see a green color VNV in front of the path. Now let's see the list of the files. See, here we have activated the virtual environment. Now let's run the server. For running the server, we have to change the directory to the respected backend folder. Now by executing this command, we have to run the server. So we are running the server by executing this command. We will successfully run the server. See, our server is in running stage. Now by clicking on new terminal, we have to give any example prompt. Let's forsake I'm giving I'm giving this prompt. See, the prompt is what is an orange, and we are invoking the rest method in this main link. And after executing this command, we will get the respective response for the given prompt. Let's forsake I'm giving another prompt. Uh, what is an what is generative AI? See, we will get the uh, respective answer of the generative AI. Like generative AI refers to a branch of artificial intelligence, etc. So by this, uh, in general, we are seeing ChatGPT. ChatGPT is a separate website app. In that, we are uh, searching for our prompts. But here, our projects will replicate the ChatGPT into our own systems, and we can see the prompts and the answers in your system itself. And now this is about the backend. Now the front end will be explained by another speaker, MD Tejasri. Over to Tejasri.
Thank you so much, Sreelekha, for the wonderful session, and it was good to know that we are able to create our own flavored chat GPT. It's all thanks to all AI experts who created this wonderful things and made our lives easy and possible. Okay, so thanks, folks who have learned something new. Let me welcome
Thank you, sir, for giving
Tejasri.
this.
Tejasri, is your screen in share?
Yeah, sir, it's
This one? Okay, go.
hello everyone. My name is E Tejashree. I'm from BTech third year. I'm still a learner. Apologize if I do any mistakes. Please fasten your seatbelts. Now let's get into start. Now we have built a backend. It's time to focus on a front-end experience. Today, we will build a beautiful responsive user interfaces for our chat app using React and Tailwind. By end of this section, we will have a fully functional chat interface ready to interact with our backend. And let's start our technology like we are using today. First, React is a React is a powerful JavaScript library for building user interfaces. It's time us to break down a app into reusable components, making our code more modified and manageable. Tailwind CSS. It is a firstly CSS framework and enables us style our app quickly by using predefined classes. It's designed to help us to build custom design into having a written and custom CSS from a script. Vite is a build tool that provides faster and effectively development and environment. It is a building into a support for the JavaScript framework like React, making it super fast to get started. And lastly, the Flask is a lightweighted Python work. We will be interacting a front end with a next section. It will be handle the backend logic such as processing required and sending response. Now let's get into the code. Firstly, setting up a React project. Here I'm taking a folder in work, and in the code I'm showing the React and TypeScript. Let's copy this and paste it. Enter. Now you can see that the frameworks which we have select. Now we can select the React. Enter. Now that we have used TypeScript, and let's go to the another. Let's copy this command. Enter. Now you can see that the installation and clouding is going on this, and in this process the tailwind is going to install. And next, let's install the tailwind. Now the tailwind process is installing. It's easy to design and understandable script is going on here. Next, now in this code, the tailwind configuration is going to explain. This contents is shown as a. These are the functions that we are going to use in this file, that we are going to use as a. Tailwind should look like a class name, and like index.html, screen, source, and next one is theme. These are called as theme customization, and font family is a set of that font family we are using a inter. Next, these functions are setting up into, and these are the central contents that are adding into optional horizontally padding that we are definitely breakpoints are using in this are SM and MD, LG, XL. These are the customs we are using in this. And this extend is nothing but it's an empty object here, and we are using for a add custom and tailwind defined themes. This we are using here as a themes. And plugins, there are no plugins that we are using in this project because it is in a file is empty. Next, TS config app. In this, we are showing this files as a ts build inform file. It's nothing but a TypeScript to build a information, and the target is that we are showing a JavaScript version as ES 2020. Use define for a class file. This enables the model class fields and the libraries that we are using here as a ES2020 domains. These are the libraries that we are using, and modules. This ES module that we are using in this skip lib check. This is a faster for the faster complex we are using this, and blunder mode. In this module that we are using a user for the styling purpose, we are taking these tools and web package, and allows importing TS extendants, allows importing as a for importing the sources, and isolate modules we are using a ensure that each file to train as an isolate module, and module define. These are the modules. that will be on focus, and next one, no emit. It's a output that file outputting the files using a limit of the type checking only. JS JSX is a React. We are taking a React section in this. Linting. Here the script is an a checking purpose of the option and the no user. This are the disallow. This we are using a disallowing the variable, and this parameter we are using a unused function as a parameter, and the no fall through a case in switch is ensuring a fall through in the switch cases. And pretending, this one is we are using a pretending side effects. Include is a source that we are taking a source from the files. Next, this tsconfig.json is a file. In this file is referred to the files is an empty error, meaning no space files are included directly in this search configuration. Specify files can be listened into individual TypeScripts, but in this case it is not being used. Here the in this case we are not gonna use in this case reference. And these are two paths that we are going to use in this. First one, the lightly the main configuration is for a application. The second one is lightly for a configuration specify, that shows the specify to the node JS for the environment. Finally, the main point in this project refers to manage multiple TypeScripts. Configuration allows them to use together for the large projects, typically for the building a TypeScript, managing different builds, setup, app version, node environment. Next one, tsconfig node JSON. In this, you can see we have already repeated that one. This is a configuration of the TypeScript, and Node.js project is used in a with. It's obediently of the project. We are in this. We are using a ES 2022 and 2023. This is the futures we are using in this, and likely we are using a type checking only. Type checking only. Next one. Just give me a minute. Now the width. Now here we can see the HTTP. The width configuration is nothing but a setting up a customized width project. Here the importing modules. The importing modules that we are taking as a defined config. This is helpful for a function to the width to define a configuration in a type space, and it help to the TypeScript understand and a configuration structure. And the React, here we are using as a React plugin to importing a width into a width.js plugin to React. Next one, packages. Now let's go to the packages. In this, the main part, the packages are listed as a dependency scripted and setting up for a Node.js project. Here, breakdowns of the keys. First of all, the name is the name we have given clone gain, and privately we are using for the meaning that it is not a publicly, and the version is 000. Type, the module type is a ES module type, and the scripted are the commands that we are run the script. Devs is a bit of to start the developing the server, and the develop is a run type script. Next one, here the dependency font awesome and font. These are the dependency that we are used. Dev develop dependency that we are gonna use in this libraries used during a development. ESLint. These are the lints that we are using a quality and style check, and the TypeScripts. Tailwind CSS. And here the Tailwind CSS is a to framework, and the port CSS we are using. And here all the project is main about the Tailwind and a React and TypeScripts that ESLint is using. And the TypeScript is a supporting a server. And next one, locking system, that it is a generating by the npm when the run npm is installed. It's managed the purpose to lock the extract version as a dependency install in a ensuring consist and the different environment. 1 minute. These are all about a speeding and installation and log dependency versions and ensuring the consistency. And this in this file, that ensuring the project dependency are stable and same as a construct. And port css config. In this plugins, in this we are using a plugins as a Tailwind CSS. It's to the build the projects. Its project is your CSS. Includes only the styles that are used in a HTML and JSX files to making a CSS as a smaller. Auto prefixed. Here auto prefixed is used. This plugged automatically added and CSS run where the necessaries are ensuring conflicting with a version browser. And let's go to the main part of this section. Index.html. Firstly, in this code, the index.html are included as a browser tab that we are using a main part as a inter. For the font, that is a Google font, which makes the page responsible and a distance and viewpoint. Now in this, we can go to the main part as a script module and script mode and create a root. Firstly, the script mode is for a React that help identify and problems to in a application during the development. It doesn't affect the produced build. Create root. The method is React 18 that creates the rendering and components, replacing React DOM for the render from earlier React version. That in main section, these are the points of mainly the point in the main section. The mainly point is index.css. Let's go to index.css. You can see here the font that we have specifiedly used in a background, and the font is a inter, that font family you can see here. And let's go to the main, and it's the app section. In the app, the components are mainly used in this, that we are using as In the app we are using a components as a sidebar, header, chat, footer. Let's go to the footers chat part we are using that specifically the if the any mistake is gone in the code, we don't need to change the whole code, just the change the similar that what we can change, where we can change, that we can change there. Now you can see I'm gonna change here. Firstly the server is running backend, so let's go. I'm running the installation and you can see the front end. Here I'm going to change the header and chart and slide bars. You can see now I'm changing a chart part. Open AI. Here I'm placing high. And you can see now the changes has happened. And similarly, I'm going to change this. I'm going to delete. And footer. Here the footer, I'm going to keep .NET has a footer, and I'm running the terminal. Now you can see the changes .NET has came. And header similarly we can change header also. Here we can change the again high. The header part is also changed. Now the sidebars. Just give me a minute. Log out.
You can add some text on the go back. I think
Yes,
logout
sir.
there is a mistake. Go back. No, in that text. Remove that logout and add something in the new chat. Just a label.
Should I add a high?
Hi here. That's it. Cool.
Okay, sir. Yeah, now you can see login high. Like this we can change the whatever we want in the code. And if we don't need to do any changes wholly. And and this is my part. Let's continue by the Soumya by the more advanced and about the front end. Thank you.
Thanks, Tejasvi, for walking us through this. And it was a wonderful session. Thanks. Soumya, your screen. Could you please share your screen? Soumya, is this your screen? You ready? Soumya, are you ready?
Yes, sir.
Okay, go ahead.
Hello everyone, I'm Soumya, a second year BTech student, and today I am excited to guide you through connecting our React frontend and the Flask backend. In the previous session, Tejasri built an amazing UI, and it's now time to bring it to life by making it functional. Today, we are going to integrate this frontend with our Flask backend will enable us to process data and deliver real-time responses. To give you some context, modern applications are often made up of two main components. One is front-end and the other is backend. The front-end is everything the user interacts with the UI that you see, and the backend, on the other hand, handles data processing, business logic, and communicates with databases. Uh, React is our tool for building the UI, while Flask is whatever powers the backend. The front end and the backend needs to communicate with each other for the app to be functional. For example, when a user inputs a query, the front end sends the data to the backend and which processes it and sends back a response. Without that interaction, the app would be just static. Today, I'll be focused on two major keys. One is handling course issue, and the other is making API calls. When our front end and back end are running on different ports, like localhost 3000 for React and localhost 5009 for Flask, we need to manage CORS, which is famously known as cross origin resource sharing. CORS allows us to enable communication between these two servers, and without it, you will run into errors like blocked by CORS policies in the browser. And secondly, we'll be focused on making API calls. Once CORS is sorted, we'll set up the actual API calls in React to send user data to Flask, which will process the request and return a response. This will allow our front end to dynamically update with the real time information from the backend. By the end of this session, our React UI will be fully connected to the Flask backend and sending user prompts and receiving AI generated response. Let me show you. We'll be fetching an error here. See, here the completions are not completed because we are facing with an course error issue. That is because I have in the backend, I have commented the course app line. So we are raising with this issue. So firstly, before we dive into making API calls between React and Flask, there is an important issue. We need to ensure that our Flask backend allows requests from the React frontend. This is where the CORS comes into play. Firstly, let me explain you what CORS is. It is a security feature implemented by browsers that controls how resources can be requested from different domain than the one the resources originated from. It ensures that web pages can't maliciously access data from other websites without permission. Uh, there is a reason why we use CORS, right? So it's necessary in development when we work with a React frontend and a Flask backend. They often run on different ports. The backend is running on the port number 5990. See here. The backend is running on the port number 5990 and the front end is running on the port number 5174. So These are technically two different origins because they have different ports, even though they are on the same local machines. Browsers follow a security rule called same origin policy. This policy blocks a web page from making requests to a different origin to prevent potential malicious activity. In our case, the frontend wants to make a request to the backend, but the browser sees this is a request to a different origin and blocks it unless the server explicitly allows it. That's where cards come in. So, firstly, to implement this, we have to install Flask cores. Uh, using using this command, we have installed Flask cores, and secondly, in app.py, we have imported some packages from Flask cores. See here, we have imported, and also we have to update those packages. uh, what this does is a simple but powerful. It allows the React app running on localhost 5174 to 5009 without browsing blocking those requests. By adding a CORS app, we have told Flask to accept requests from any origin. This is great for development, but in a production environment, you might want to restrict access to only specific origins for security reasons. So let me show you. I have uncommented this course app. So see, we are getting the output. So this is the what majorly the course will play. And next, secondly, I am going to focus on setting up API calls in React. This will be done in the front end. So, yep. We have to create a file named api.ts in your React project. In this code, will be seen on many functions like fetch, method, headers, body. Let me tell you what exactly those functions do the work. Firstly, the fetch function is built into JavaScript and is used to make HTTP requests. In this case, we are sending a post request to the Flask server running at HTTP on the port number 5009. This is the endpoint where Flask is expecting to receive the prompts. In next, this method okay, this method tells the server that we are sending data, the user prompt to it. Next, the header. Here we specify that we are sending JSON data in the request body. The server will expect and understand this. Next, this body JSON stringify prompt. This part converts the prompt JavaScript object into a JSON string. The prompt is the user's input, which we will send to the backend. Once the request is made, the server will send a response. We check if the response is successfully by checking res.ok, this condition. This checks whether the HTTP response status is in the 200 to 299 range, indicating success. If the status code indicates failure, like around 400 or 500 range, an error will be thrown, like error fetching response, please try again later, like that. And if the request is successful, we return the response body as a string. This is the data we expect from the backend, likely a response from AI, like yes, a response from AI. Next, we have to handle some errors which are raised. So we used here catch error. Any errors that occur will be logged to the console and we return a user-friendly error message like error fetching response. This utility function sends a post request to our Flask backend and handles errors gracefully. By separating the API logic, we can reuse the function across multiple components without duplicating the code. Next, we'll be focused on modifying chat.tx to send request. So after we are typing our prompt, we have to send to the project, right? So we use the send request button in this chat.tsx file. It's time to integrate it into the chat.tx component. In this session, I'll walk you through the process of updating the comment component so that it can send requests to our Flask backend and display the AI response to the UI. Before we start modifying the chat.ts component, we need to import fetch AI response function that we created in the previous step. So this has been written in api.tx file, right? I'll show you. See here, we have written this complete fetch AI response. This will allow the component to send requests to the backend and fetch AI response. So here we have used use state and fetch AI response, prompt response, etc. Right? So let me tell you, let me define you each and every keyword. Firstly, this use state is a React hook that lets us manage state in the component. It will return a stateful value and a function to update it. And next, this fetch AI response is a function we created to send requests to the Flask backend. By importing fetch AI response, we can use it inside the component to make API calls. Next, secondly, we need to manage two pieces of state. One for the user's input, and second for the AI response. This prompt will store the text that the user types in. So it will take the input from the user and stores here. Next, this response will store the AI response, which we will display after making the API call. Next, we will define a function called send request. This function will be triggered when the user clicks send button. It will send the prompt to the Flask backend and update the response state with the AI reply. This will trigger when updates the UI to indicate that the app is waiting for a response. And next, this await sends the prompt to the backend, waits for the response, and stores it in the AI response variable. And next, this set response. Once the AI sends a response, we update the UI to display the result. Next, this complete UI. This is complete a UI layer. So let's build the user interface. We'll create a simple layout with a text area for the user to type their questions, a button to send the request, and a section to display the AI response. We have provided a text area. See here, we have provided a text area to take the user's input and response display. Also, we have given a place to display the response and this send button, which when clicked it triggers the send request function, sending the prompt to the Flask backend and updating the UI with the response. And that's it, guys. Our React UI is now fully connected to the Flask backend, and we can send and receive data seamlessly between the two. It's exciting to see the front end and backend communicating as expected. Let's take a moment to recap everything we have done so far and reinforce the key concepts. Firstly, we have enabled a course in Flask, and secondly, creating a reusable API utility in the React. In React, we have created a separate API utility file to send communication with the Flask backend and updating the chat.tsx components We integrated the API utility in our chat.tx component. We set up state management using React hooks to store the user's input and the AI's response. Uh, I hope you found today's session informative and enjoyable. Before I wrap up, feel free to ask any questions. Don't hesitate to reach out. Once again, thank you for your attention and participation, guys.
Thanks so much, Soumya. Others can also come into your screen. Guys, please come onto the same screen where Soumya is here.
Screen share.
No, they can come onto your screen, sit together there. Okay. Guys, I would like to thank all these people. They are the first time speakers. Manikanta, Sreelekha, Tejasri, and Soumya. All these 4 people are first time speakers, and I really thank them for bringing in what they've learned and sharing this with the community. And they will be time and again coming and speaking and doing a lot of these community service events and sharing their knowledge. And this is their first step, and I will thank them for that. Okay. Anything you guys would like to speak one by one? One sentence. You guys can unmute and you can go ahead and speak before we close the bridge.
Yes, sir. I would like to be thankful for the .NET Veteran House for giving this opportunity. In this course of period, we have learned a lot, and the thing we demonstrated here is the huge learning in our past few days.
Okay. Anything from Sreelekha? The same order, Tejasri and Soumya. Unmute.
Hello, sir.
Yeah, go ahead.
Thanks
Go ahead.
to you, especially to you and .NET learners for giving this opportunity, sir. You guided us very well, and you trained and bring us in front of these digital, digital what, digital platform. And thank you, sir.
Yeah, thanks from my side too, sir. Thanks a lot for giving me this opportunity.
Okay, you guys have done good because even though you guys are first time speakers, you did excellent. Tejasri, any final point before we close this bridge? What?
Yeah, sir. Thank you so much for giving this opportunity. Actually, you guide us very much. Thanks for
Okay, so guys, we'll come back with another exciting piece next month. So this month we stopped it here. So next month we will bring in different pieces, not only AI. We'll start with maybe the algorithms, which is data structures and algorithms, which is very much needed for all interviews. So that we will bring in, and beginner friendly. Rohit, we will be doing C# series also. Everything you can do it with C#, like a little bit of C# and starting with the minimal API and full-blown controller API, little bit of Razor pages, Blazor, MVC. We'll do tons of things. Good that someone who's joining, if they post what is that they needed, we'll be more focusing on that. But at least one talk we will keep it AI. Mine, if you see that entire year, I'll be focusing on Aspire, which is a distributed application, and I think that is going to take over the world pretty soon, if I'm not wrong, if I'm not exaggerating. .NET Aspire. So I'll stick to .NET Aspire. and see that how can we bring at least 2 to 3 different topics, something in Python, a bit of .NET flavored, and data structures and algorithms for sure. Okay, so we'll do our best to bring in. Okay, you can ping us, Rohit, on our LinkedIn's. You can see our LinkedIn, so we can have a offline discussion. Okay. Thanks for joining. Hope you guys have learned. Good night from .NET Learners House and these excellent AI innovators. Bye.